Canada, and so forth. Similar for MS, there's well-documented studies. And certainly it's well documented that the incidence of diabetes is higher in countries that are industrialized or very well developed and wealthy countries. But again, there could be many factors. There could be nutrition. There could be the incidence of parasites or virus infections. There could be the exposure to the sunlight and vitamin D3 production. All these things are being argued, but it's very difficult epidemiologically to prove any single one of these factors as a causative factor. The other thing, what we don't fully understand is the degree of islet inflammation that differs largely between humans and mice. In mice, you get much more inflammation in islets. In humans, you get much less, and we are not in a good position to estimate at this point what that means. So I gave you many factors that could still be worthwhile studying. So many of you, if you decide to go into type 1 diabetes, there's a lot of ground to be covered and a lot of work to be done. So let's get to the issue of viruses in type 1 diabetes. One way how viruses could cause diabetes is that they directly infect beta cells and they lyse the beta cells. So you lose the beta cells that are virally infected. Now one can, in vitro, find certain enteroviruses that do that. And they're rare. And so probably this event overall, although it has been described in certain cases of fulminant early childhood diabetes, is a rare event. This is not your common type 1 diabetes case. It might sometimes occur in young children. The Japanese have now isolated some viruses of acute cases of diabetes. The main reason to assume that it's not so common is if it were the common occurrence for type 1 diabetes, we would have an easy time to find these cases. Because if you get a viral syndrome, you get a fever, and then a week later all your beta cells are gone, clinically that would be relatively easy to establish this correlation, right? And this has not been happening in most cases, except for a few early childhood cases. So the scenario that the virus kills the beta cells is probably unlikely, not impossible, but unlikely as a common cause for type 1 diabetes. So, as said here. Now we come to molecular mimicry. This becomes much more complicated, and we have worked on this probably for the last 10-15 years, mainly also because I trained with Michael Oldstone, and Michael Oldstone was a strong protagonist of the molecular mimicry hypothesis for many different diseases. What one can find based on animal models when you study molecular mimicry in this type of scenario is one very important paradigm, and that is, if you take an animal that's completely healthy and not diabetes prone, and you have a cross-reactivity between an antigen expressed in beta cells and a virus antigen, which is really molecular mimicry, then to go over the threshold to induce disease is very, very, very difficult experimentally. This we have studied in a virus-induced model, this WIP-LCMV model, in detail. And you can take antigens that are identical between the virus and transgenically expressed in the beta cell, and you get diabetes easily. You can antigens that are mimic, where there's good cross-reactivity, and you get zero diabetes. So for me, to induce with mimicry autoimmunity in an otherwise non-predisposed situation, from scratch, for me, the glass is half empty. This is difficult to do. That doesn't prove by any means that mimicry is not important. There's other situation that can occur, and we have created this a while ago in an experimental model, and of course Kristen has published this in JCI, is you can ask the question, what if you have already a pre-existing inflammation and then you have mimicry? And indeed, in this case, mimicry can accelerate the process. So in other words, if you have humans at risk to develop type 1 diabetes, and you superimpose cross-reactivity between islet antigens and the virus antigen, then you can create scenarios where you can accelerate the disease. And that might actually be your common, more likely human scenario. Conversely, you can also say, and I was thinking along the similar line, and Lindsay Witten has called this fertile field. If you already have some type of inflammatory damage, let's say you have a pathogen that affects a certain organ, and then you have cross-reactivity, this organ is already conditioned, and you will have an easier time to induce some persisting autoimmune disease. There are some examples in MS with Tyler's virus and Steve Miller's hands that works exactly like this, where the virus has to persist. Whether mimicry after you have an insult can run on its own is difficult to estimate. Certainly your heart disease data argue that repeated insults will facilitate the development of disease. I think at the end of the day all this fits along the same line. That mimicry needs a little bit of help to be pathogenically important, and the help can come either conditioned in the organ or through repeated insults with the offending pathogen. But it's less likely that you will induce it from scratch, in my opinion.
In our model of rheumatic heart disease, we think that antibodies against T molecules that are also triggered by these streptococcus would be the triggering factor and would recruit cells to the heart. That is the first inflammation spot that could take the ground to develop the inflammation and the mimicry.
That's a very interesting hypothesis, and it has not been studied in type 1 diabetes at all. People don't know about this. And another unknown, I should have put it on the list in the beginning, is how on earth lymphocytes become interested in going into the area of the islet. People don't know that, unless you propose you have a pre-existing viral inflammation. But antibodies against adhesion molecules could be constituting one of the mechanisms how this happens. And nobody in type 1 diabetes has studied that. They have studied certain chemokines like IP10 that recruit lymphocytes to the islets. But still, to have IP10 in the islet, somebody's got to induce this first before it's upregulated, right? So it's a very interesting hypothesis in type 1 diabetes, probably should be evaluated. Nobody has at this point evaluated that. So we spoke about the fertile field hypothesis and its importance for molecular mimicry, but you could in general say, not only postulating molecular mimicry, that if you have some insult to the beta cell that creates a fertile field, maybe even these antibodies to adhesion molecules in the local area, that any type of autoreactivity, whether this is mimicry or just plain autoreactivity, will have an easier time to cause damage. Now I'll show you some data how this could occur, where I try to draw a parallel between the animal model and the human situation, and it will be, at least should be, some food for thought about how fertile field or virus infection could play an instrumental role in type 1 diabetes. So here's some interesting data. These are not from our lab. They're from Francesco Dotter. Very similar data in Alan Fowlis's hand, where I looked at a large cohort. What they find is that they have commonly in the area of human islets, these are human islets, MHC class 1 upregulation, and also in Dotter's hands maybe some interferon upregulation, although this is controversial. This, if that commonly occurs in human patients, argues strongly for viral cause, because these systems, class 1 and interferon, are usually tightly regulated and they are commonly induced by viruses. And there's incidentally a recent paper by John Todd that has associated rare polymorphisms in interferon response genes with increased incidence of type 1 diabetes in his cohort after studying many patients. This was, I think the paper was in Science. It was a good paper because it showed that these rare incidences in interferon response can be associated with type 1 diabetes.